Here we are at part 2. So let's write down this problem. Alright, write down this problem and see if it shows up. Pretty good. And this is number 35, and because we are restricting ourselves between 0 and 2 pi, we are normally going to find whatever angle is multiplied here. This is multiplied by 2. We're expecting 4 answers. If it had been tripled, we expect 6. That's not always true, but it's often true. So this is understood to be the values that x can take on, but we have doubled them. So our range will double. So 0 to 4 pi is where we're going to look for our answers. So that's twice around the circle. So let's begin. Alright, this one algebraically is complete. The trig function is by itself. We cannot mess with that 2 because it is stuck inviolably, cannot be violated or broken up. So that is stuck together. So we pull it out as a package and we ask ourselves, where is this package? What values can this package take such that the cosine of it will equal 1/2? So our unit circle will help us with that. And that happens at pi over 3. And another place that it happens is 5 pi over 2. And that's one around the circle. So then we come back and we start spinning these to see if there's more answers in this range. Let me move this up here, 0, 4 pi, and it gives me more working room. So I'm going to add 2 pi, that's one circle, that's what I call spinning it. So I'm at pi over 3, and I'm going to take it around once more. 2 is 6/3 pi, so when I add 1/3 pi and 6/3 pi, I get 7/3 pi. And is that out of range? Well, our range is up to 4, so 3 and goes into 7, 2 and a little more, so no, we're not out of range. So we accept this answer, and we accept this answer. We've already spun that one, so I just check it off. How about this answer? Let's spin it. This is a good answer. When we add 2 pi to that, remember we're adding 6/3. 6/3, this wasn't 5 pi over 2, was it? Yeah, it was 5 pi over 3, sorry. Pi over 3, and 1/3 pi, 2/3 pi, 3/3 pi, 4/3 pi, 5/3 pi. Alright, there we go, that looks better. 6 over 3 pi plus 5 pi over 3 is 11 pi over 3. And is that out of range? It is not. 3 into 11 goes, 3 into 11 goes a little more than 3, so 11/3 pi is good, healthy answer. So I spun this one. Let me go up here and take this one around the bend. Here we go, loop-de-loo, adding 6/3 and 7/3. We get 13/3. So 13/3 pi. 3 into 13 goes 4 point something, so it's larger than that. So we did go out of range. So we ended up with 4 answers for 2x. Let's gather them on one line. We've got pi over 3, 5 pi over 3, 7 pi over 3, and 11 pi over 3. Alright. Now, that is the answer for 2x. And finally, because we already took the cosine, we can divide this now. There's no trig function preventing us from. So I don't want to know what 2x equals. At the end of the story, I want to know what x equals. So I have to divide all of these by 2. And when I do that, the fraction work is minimal. We have pi over 3 divided by 2 is pi over 6. And this is 5 pi over 6. And this is 7 pi over 6. And this is 11 pi over 6. Alright, so those are the 4 answers to this problem. And I'd like you to try one that is very much like this. So write this down and all the steps to get credit for number 35. And I want you to do one just like it. And it's not on your homework assignment that I have already assigned. It's this one for tonight. So I would like you to bring this one done completed following this line of thinking. So let me give you that problem, and you can just stick it in your comp book or on a piece of paper. I'll ask you to put it up on the board when you come in. So let us do this one. Due tonight. This is a due tonight one. 2 sine of 3x equals minus 1. And we're going to cut that off in between 0 and 2 pi. So there you go. See what you can do with that. And recall that probably it's going to be 6 answers. So have at it. See you tomorrow.